Welcome back, reinforcement learning. This session I explain a different approach to reinforcement learning. Okay, in different approach to reinforcement learning is the evolutionary approach in reinforcement learning. Okay, in previous sessions we discussed different reinforcement learning techniques, DQN, deep Q network, and reinforcement algorithm, that is a policy based approach. Okay, these are DQN and reinforcement algorithms, all are the previous discussed approaches or methods. We are rely or depend on back propagation to optimize the neural network parameters, to optimize the parameter values to get the best results, to the best policies, optimal policies. They rely on back propagation, so it requires the differentiation calculations. So here this different back propagation is a drawback in this back propagation is we have to tune the multiple hyperparameters. Tune the multiple parameters are required in backward propagation. They raise the noise in optimization methods, and they also face the challenges with stability and convergence. So to overcome this problems, the evolutionary algorithm approach is invented in reinforcement learning by it is inspired by the natural science, natural selection, the natural science, Mendel's theorem, those type of methodologies. We are using evolutionary algorithms implementation. They are not use the backward free models. They are evolutionary algorithms are backward back propagation free approaches, and they are not required differentiation in to get the best policies in reinforcement learning. So evolutionary algorithms are back propagation free approaches. They are not required differentiability calculations in that algorithms. So it is the evolutionary approach is the back propagation free approach. So in traditional reinforcement learning, in past algorithms, the agent interact with the environment, and based on that interaction they are collected the experiences and then learn from those experiences. We repeat that process the multiple times, number of epochs, until the agent stop the learning based on that epochs. The agent interact the action and takes the action and interact with that action environment. He got some reward and change the environment state. Okay, this process is continued in traditional reinforcement learning approaches. So these are we followed in deep Q learning process and policy based methodologies. So here evolutionary algorithms, the evolutionary algorithms are different approach we are followed here. They are not they are not required the back propagation, the gradient based optimization are not required in evolutionary algorithms. They optimize the parameters by interactively selecting the most successful agents from propagation, agent from population based on the fitness score. Based on the fitness score, the evolutionary algorithms optimize the models, optimize model parameters by interactively selecting the most successful agent from population based on the agent's fitness score in that model, in that problem. Instead of gradient based approaches, optimization methods, this approach is genetic inspired techniques. Genetic inspired techniques, they are inspired from natural science. They are like the operations are like selection, mutation, or crossover. This type of operations we are performed in evolutionary algorithms to evaluate the population of agents for generation. So here evolutionary algorithms optimize the model parameters by interactively selecting the most successful agent from population based on fitness score. The fitness score, fitness based selection is we have followed the evolutionary methodologies. Unlike DQN and policy gradient methods, they are adjust the model weight based on gradients. They adjust the parameters based on gradients. Here evolutionary methods score each agent's performance in the environment. Each agent performance we are calculated the fitness score. This is agents with higher score have the higher probability of contributing genetic material to the next generation. So allowing the gradual evolution of optimal policy without back propagation. So which agent have the best perform, that is the best fitness score for that problem. So we are in evolutionary algorithms we are using fitness based selection of the agents in evaluation of the models. So here population of agents interact with the environment and determine the fitness ranked population. The fitness ranked population is filtered to the produce a population of most fit agents. Here we calculate the most fit agents. After that the most fit agents are bred to make a new generation agents. Again new generation agents interact with the environment, but again this process is continued. So evolutionary algorithms are different from gradient descent based optimization techniques. With the evolutionary strategies we generate agents and pass the most favorable weights down to the subsequent agents. So population of agent interact with the environment, determine the fitness ranked population, is filtered to the producer most fit agents. The most fit agents are bred to make a new generation agents. The new generation agents again interact with the environment. Okay, this is the process in evolutionary algorithms. In evolutionary algorithms, the advantage of evolutionary algorithms is we execute the agents parallelly, the parallel learning process. Evolutionary algorithms allow for parallel evolution of multiple agents, increasing computational efficiency. Individual agents don't need to back propagation gradients, so they are not interacted with others. So they are executed independently. So the agents don't need a back propagation gradients. This approach is easy to scale across distributed systems, make well suited for high performance computing environments. So the evolutionary algorithms allows the parallel learning. So gradient, it is a gradient free optimization. So it is not required the differential calculation. It is not required to optimize the different hyperparameters, learning rate, batch size, they are not required. So this is the easily we can use in any type of environment which are not required the backward propagation. And the algorithm steps in evolution algorithm is, the first one is initialize the population. So a population of agents is initialized. All agents in that population must be initialized, each with randomly assigned parameters, that are the weights, and evaluate the fitness of each agent. Each agent interacts with the environment and fitness score is calculated for that agents in that environment. Based on the performance we calculate the fitness score. Selection of the top performers, based on the fitness scores of the all agents, we select the top performers. The top performer agents are selected based on fitness scores. Selection method may include the ranking or anything. We follow some rules to get the top performers, and after that we select the top performers. We are apply the crossover or mutations. We are apply the genetic methods to combine the best, to get the best agents. New agents are created by combining parameters from selected agent, that are the best performance agents. They are either crossover or introducing slight random modification, that is a mutation, to maintain diversity in the population. This process encourages exploration of the solution space. It is like a exploitation and exploration process in the traditional reinforcement learning, and this process is repeated for multiple generations, gradually evaluating the population toward optimal policies without gradient based learning. So these are the steps we are applied in evolutionary algorithms. First one, initialize the population. Next, evaluate the fitness score and selection of the top performers, and crossover or mutation, and repeat this above steps. Okay, next, what are the advantages of the evolutionary algorithms? The evolutionary algorithms are not required fine tune the hyperparameters like a learning rate, optimizers, batch sizes. Okay, these are not required in evolutionary algorithms to fit the tune the hyperparameters. Next one is it is a gradient backward propagation free methods. So it is not differentiable models. They are not required the differentiation. Differentiability is not required in evolutionary models, and it allows the parallel learning. So these are the advantages of the evolutionary algorithms. Hyperparameter simplicity, they are not required for tune the hyperparameters, and non-differentiable models and parallel learning is allowed. An example case, we apply the evolution algorithms to any environment like grid world. In grid world, agents are initialized with random weights and taken with the maximum their reward. After each generation, the highest score agents are selected, bred them, and muted to form a new population. Over the successive generation, the agents evolve more effective strategies for navigating grid world without back propagation, achieving the competitive results to traditional reinforcement learning methods. So evolutionary algorithms are provide the flexible and gradient free approach to reinforcement learning. They are inspired by the principles of the natural selection and to optimize agents, and these methods are reduce the dependence of the hyperparameters tuning, and also allows for the non-differentiable model architectures, and RL it is a parallel learning also allowed. So these evolution algorithms expanding the reinforcement learning potential in different applications and complex environments. Thank you.